Hello everyone, so today we are going to develop a model regarding the pressurization of the vessel during emergency fire case. So in emergency fire case, the safety system or logical safety system will induce the SDV, shutdown valve, to be closed and isolate the vessel. Therefore, in order to reduce the possibility of failure of the vessel, the depressurization system should be applied in this vessel by releasing the inventory commonly consisting of gas. Because in the event of the fire, when the vessel is exposed by high temperature, the vessel strength, mechanical strength of this vessel will deteriorate and pressure may build up as the gas or liquid inventory is heated. Therefore, decreasing the pressure vessel by using this BDV, a blow-down valve, will reduce the potential risk of equipment failure. So in the beginning, you have to prepare a stream which consists methane, propane, and normal butane, respective composition, and the operating condition of the vessel, the temperature, and the pressure. We actually do not need this one mass flow since in emergency case the vessel will be isolated by the shutdown valve. So actually we will discuss about this feature, the pressuring feature of Aspen Hysys. This feature remains useful that can be used to provide initial studies regarding the depressurization of the vessel. But however, this feature usually produces conservative result, which is desirable from a safety aspect. So we have to specify inlet operating conditions using the stream that we have prepared before. You can choose the stream one. It's okay. And I want to specify my separator with height of 1.5 meter. And Hysys will accommodate the calculation to calculate the diameter of the vessel, and I want to specify the initial liquid percent at 15%. Let's assume that the liquid at level alarm low, can assume that the liquid is 15%, and heat transfer area, Hysys will calculate by itself. We can leave it as it is because we will not use the heat loss calculation in detailed mode since we will consider the fire case only. Then we can continue, or we can leave it as it is and we will configure this one at the end. So we will set the operating mode to Fire API 521. We can leave it as it is for the C1, for C2, and for the C3 we can specify 1 because actually the C3 is the tuning factor of the weighted area. So to get the conservative result in this matter, we have to specify the C3 of 1, and I choose weighted area model using the initial liquid level. It means that a long period of the fire case, the weighted area model used in the simulation will not change over the period of time. Then in heat transfer model, we can choose known for the fire case. For Fire API 521 case, we recommend to use known at this one. For valve parameter, we actually just release the vapor contained in this vessel, so we will only consider the vapor valve only. We will use Masoneyland, actually the valve manufacturer, and the critical flow factor we can specify 1, because we want to get the worst scenario, worst result for this matter. And the CV will be specified in the another page. We can go on to options. In PV work term contribution, we can specify 100%. It means that the minimum temperature will not go down furtherly. So actually we can get the conservative result by specify the 100%. We can specify, we can leave it as it is. Actually it means that the vapor and liquid in equilibrium state. In the operating conditions, we will adapt to API 521 recommendations, which we have to depressurize the pressure within 15 minutes, but actually I want to reduce it to 4 minutes, which we can keep as it is for the time step size, and we can calculate CV. So actually this CV or valve coefficient will connect with this one, with this valve coefficient in this page. So we can specify here the initial value of the valve coefficient. Maybe we can start 1, and maximum CV state size I want to specify 3% to reduce the step size in iteration. Pressure tolerance I want increase to 100, and refer to API 521. We have to reduce the pressure of this vessel to 7 bar gauge. And actually this recommendation is only recommended in 1-inch vessel thickness. If the thickness is lesser than 1 inch, we have to use another consideration. So after all parameters have been specified, we can start our calculation and keep it as it is and click run here. So the strip charts will appear in your screen.